So today we're going to continue our look at algebra. Remember, we're building the algebraic system, talking about all the skills that you're going to need in order to be able to solve algebraic equations, which is our final goal for this class. That's where we're going. So today we're going to talk about expanding algebraic expressions. So remember, first of all, how do we know that something is algebraic? What makes it algebraic?
It has variables.
We have variables. There you go, because it has letters in it, right? And it's an expression. How do you know that it's an expression and not an equation?
Because it doesn't have an equal sign.
There's no equal symbol. Sure, and y'all can just sing out, okay? All right, good. All right, excellent. And algebraic expressions are made up of, what do we call the algebraic pieces? They're called they're just plain terms, right? Terms, yeah. Algebraic expressions are made up of a collection of terms. Remember, it's a collection of terms and mathematical symbols, including terms that are not algebraic, which are called constants, right? Don't forget the constants, too. And a constant just means a number, yeah? Because their value can never change. A letter is a variable because it varies, right? A constant is just a number because 7 can only ever be 7. Yeah? Okay, so right, let's look at our lesson. Okay, hold on just one moment. Right. One of the skills that that is imperative that you have is that you have to be able to understand how to expand brackets. So that's one of the things that we're going to be talking about today. So what we're going to be doing is talking about the concept of expanding algebraic expressions and complex algebraic expressions. So we'll talk about what that means as we go. So when you're working with brackets or parentheses, whichever you prefer, what they mean always is that you're multiplying. Okay, so what we're going to do is talk about the pieces of a bracket. So if you have a bracket, and I'm just going to use a bunch of letters, not numbers, because it's easier to talk about. What that literally means, anytime you see something right up against something like that, what is the only operation that could possibly mean without having a symbol? Multiplication, right? So we're going to talk about the process of expanding and working with brackets. So let's look at a few notes. Okay. So say, for example, we have a bracket. There are 3 different shapes of brackets that you can have, but we're going to just talk about the most basic type right now, and then we'll see how they expand that later. There are 3 steps to use to eliminate brackets. And they never change. And they must be done in this particular. So 3 steps to eliminate brackets. And you will always do them in exactly this order, always. Now, doing them in order is one of the biggest problems with brackets, one of the few things that students have trouble with brackets. The first thing you're always going to do is you'll always look inside the bracket. Inside the bracket, you're going to have some terms, all right? Or they could be numbers or whatever, and you're always going to do that first, right? So say inside a bracket you have 2 plus 3. That means that I have to do that addition first. Now, when it's algebra, can we always add everything together? Nope. We can only combine them if they're considered to be like terms, yeah? So could I add an A to a 3? No. So in this one, in the top one, I could simplify that and do a 5. But in the bottom one, I don't know what A is, so I'm not able to do those, right? So in the top one, I could do something on the inside, but in the bottom one, could I do the inside? No, because A plus 3, I don't know what those are, so I'm not able to do any math in those. So even though I couldn't do anything for inside. I still had to look there first. Second thing you're going to do is you're going to look for an exponent. Now, this is very rare, and it's probably not likely to happen with your work that we're working at this level. But if you did have an exponent, what that means is there would be a little exponent on the parentheses itself, on the bracket itself. I'm not talking about inside. That would have already been done, right? We're talking about on the outside of the parentheses or the brackets. And then finally, the last thing you do is look for a coefficient. Now, we've used that word coefficient, and we've used it as part of a term, and we said it's the number part. But remember that in reality, coefficient is simply another word for a multiplier. Right? Because if you have 3a, the coefficient is 3, right? But what does that literally mean? 3 times a, right? So what happens is that 3 is really multiplied times the a. So coefficient doesn't mean a number. Coefficient means a multiplier, right? But in a term, that multiplier is always a number. Okay? So 4a, what's the coefficient of that term? 4. And it's the coefficient because what it literally means is 4 times a. 4 is the multiplier. Okay? Well, you can also have a multiplier on a parentheses.
What does multiplier mean?
Something that you're multiplying by. Right? So this is a multiplier, means take 4 times the a. Right? It's just the thing that you're multiplying by. Okay? So a multiplier is just what you are multiplying by. How's that? That's okay. All right, so a multiplier just means what you're multiplying by. And so for a bracket, it looks a little different. When you have a multiplier, that multiplier is going to be in front of your bracket. And again, it's easy to see that this is multiplication because there's no operation symbol there. And the only operation that it can be if there is no operation symbol is what? Multiplication. Multiplication is the only operation that requires no symbol. So, what if I had this? Is the 3 a multiplier this time? Absolutely not, because we have that plus between the parentheses and the number. How about now? Is it the 3 a multiplier this time? No. It's only a multiplier if it's immediately in front of the parentheses with nothing else. No other multiplications, no other symbol between them. Now, you could see it like this. Well, actually, they would use an X, right? You could see it like that, but it's very rare. Usually, they would just put the thing together side by side. All right? So what we want to do is we want to talk about what to do in this case. And what we're going to do is we're going to use what's called the distributive property. Think about what that word means, distribute. If you're going to distribute, so let's say I had a whole bowl of candy up here, and I'm going to distribute it. What does that mean? I'm going to hand it out, right? Now, if I wanted to survive after doing that, I would hand it out the same amount to every one of you, right? Okay. I mean, otherwise I would have to hear lots of screaming, wouldn't I? Yeah? I would distribute it evenly if I was going to do that. I wouldn't give Amelia all of it and the whole bowl and then all of you one piece each, right? How happy would that make everybody?
I would. Amelia.
Yeah, you would get Amelia instead of me? Okay, well, I'm okay with that. No, that's not right. What happens is you need to make sure that you're distributing evenly, right? And the only way to make it fair is to give everybody the same amount, right? And that's what the distributive property does. So anytime you have something in front of a parentheses, This literally means that what is our multiplier? Our multiplier here is the A, right? So A, is the multiplier, which we call the coefficient, right? So A is the coefficient or multiplier. Okay. How many terms do I have inside that parentheses? Remember that terms are separated by pluses and minuses. So we have one term, and then we have a B, and then we have a C. We have a B and a C. So that means how many terms? 2, right? Remember that every time you see a plus or a minus, you know it's the beginning of a new term. So there's a B term and there's a C term inside there. Right? What's the first part of every term? It's sign. So every time you see a plus or a minus, it's a new term. So what that means is I need to take that coefficient times everything inside the parentheses. So A is the coefficient, and what you're going to do is you're simply going to multiply that coefficient times each or every, whichever word you prefer, term inside the parentheses. Okay? So if there's 2 things inside, then I'm going to multiply how many times? Twice, right? 2 times. If there are 5 things inside, then how many times am I going to multiply? 5 times, right? And so, well, we'll do an example and you'll see it. So here I have a B and a C inside, right? So I need to take my A times my B, but I also have to multiply my A times what? The C. You're distributing it throughout and multiplying. So let's look at an example. Let's say that I have, we'll just do one, A times 3B plus 2C. These are just algebraic terms. They're algebraic because they all have letters, right? First place I look is where? Inside. I need to look inside the bracket and see if there's anything I can do. I have 3B and a 2C. Are 3B and 2C like terms? No, because a B and a C can't be like terms. They don't have the same base, right? Now, what if I had 3B plus 2B? Are those like terms? Yes, and therefore I could combine them, but that's not the case in here. We have 2 different terms. Then the second thing I look for, which we're not going to have really, but I still have to get in the habit of looking for it, is a what? An exponent. Do you see an exponent here on the parentheses? No, so we're not worried about that. And the third thing I look for is something called the coefficient, which is just the multiplier right up front. Is there anything right up against this parentheses? Yes, what? The A. So that A is my multiplier. That means I need to take everything on the inside of the parentheses and multiply it by A. How many things do I have inside the parentheses? 2. Excellent, right? 2 terms. So I'm going to take the A times the 3B, and then I'm also going to take the A times the positive 2C, right? Remember when we're multiplying terms, to multiply terms, just remember the steps that we've already talked about. First, you do the sign. Then you multiply the coefficients. And again, here we're talking about the coefficients of a term, which just means the number part. But again, that really means a multiplier. So you have to make sure you really know the vocabulary, right? We're going to keep the base. And by base, I mean the letter, the variable. And what do we do to exponents when we multiply with them? Come on, guys, make me proud. Anybody? Add the exponents. When you multiply with the same base, you add the exponents, right? So a b to the second times a b to the third is a b to the 2 plus 3 or b to the 5th, right? Some of that. So make sure you're doing your homework and make sure you're studying your notes, because this is the problem that happens as we build up. You're going to forget things, right? So you've really got to make sure that you understand what's happened in the past. So let's do this multiplication. First of all, there is no sign in front of the a, so I can assume it to be what sign? Positive. There is no sign, and so we're going to take that a times our 3b. There is no sign in front of the 3, so we can assume it's also what? Positive. Well, positive times a positive just stays a positive. I'm going to write it. Do you need to write it? Exactly. You're just expanding the parentheses. All right. So then, what number is in front of the a if there is no number there? A 1. So 1 times 3 is 3. And now we'll do the variable, right? So first we do the sign, then we do the coefficient. Well, we just haven't gotten to that part yet, right? This one just is a simple term, but you have to think of each piece. If you think of it as just the a times b, then you're not getting each piece. You have to make sure you take care of the 3 as well, right? Anytime you're multiplying terms, you need to think of all 4 steps, because otherwise you just get in the habit of looking for one thing and not all of them, all right? And now finally, a times b. Can you multiply an a times a b?
No.
So what do you get when you multiply a times b? Just ab. And I'm done with that term. But am I done with the multiplication? No. So I still have to take my positive 1a times my positive 2c.
How do you know if they're positive?
If they don't have a minus in front of them, they're automatically positive, right? So is this one positive? No, because it has the minus in front of it, so it's not positive, right? Okay. Is this one positive? Yes, because there is no sign. That all means I automatically assume it's positive. Good. So now let's do the other ones. First thing I need to do is determine the what? Circling it down here. Sign. So here's a positive times another positive, which stays what? Positive. Now this time I have to have the plus. The plus I put in the front of it really is not necessary. But this time I have to have the plus because we're separating 2 terms, right? So it's not optional when it's between terms. Then I'll do the what? What's the next part? Multiply the coefficients. So it's a 1 times a what? Which gives me 2. There we go. And then I'll do the multiplication with the bases. I would normally keep the base and add the exponents, but an a and a c are not the same letter, are they? So I'm just going to multiply a times c, which is going to give me what? AC. And that is your completed answer. Now again, do you need that plus in front of the 3? No, I just did it for effect to show. So you're certainly welcome to leave that off. Now, could I get rid of this plus between those 2? Absolutely not. You have to have that one. Okay? All right. So let's go to some of their examples so that we can see a few more of these. So you see that they've done 3x plus 2. So they started you off with fewer variables than I did, but that's perfectly fine. So anytime that you have a number in front of a parentheses, first place I look is inside. Inside I have x plus 2. Can I combine an x and a 2? Be careful. Can I add them? They're not like terms, right? So no, I can't combine them. Is there an exponent on the parentheses? No, if there was, it would be here like that, right? But there's not. Is there a coefficient or a multiplier? Yes, the multiplier here is 3. And that means to take the 3 times how many of the things inside? Well, everything inside, right? So, how many terms do I have inside? 2. I have an x and I have a what? A positive 2, right? If you do have a sign, you need to say the sign. So otherwise you won't remember it. So that means I have to take that 3 times both of them. So first, we simply take the 3 times the x. And what is 3 times x going to give me? 3x, because you can't multiply a 3 and an x, so all you do is stick them together. Then, done with that, so now I have to take the 3 times the positive 2, and because it has a sign up there, I'm going to have a sign in my answer. So it's a positive 3 times a positive 2, which is going to give me what sign? Positive times a positive stays positive. And then I can multiply the two numbers. 3 times 2 is what? 6. And that is my completed answer. Now you see what they did was they're just showing you the multiplication here. Right? So you can expand it like this if it helps you. You can write it off to the side so that you know exactly what you're doing for each piece. It makes no difference to me. You write as much or as little as you need to be able to get the correct answer. Let's look at some more of these. Again, this is a critical skill. If you can't do this, then you're going to be in trouble from now on. Okay? So I need for you to really get the concept. So we have 3 times 4x plus 1. So we have a bracket, right? How many steps for clearing a bracket? 3. First thing you do is look to see if there's anything you can do inside. This is very unusual, but it will occur later. So you need to get in good habits now. So inside I have 4x plus 1. Can I add a 4x and a 1? No. Okay? I think we can do that a little more quietly. Yeah, come on. All right. Then you look to see if you have an exponent, guys. So, do you have an exponent? Now, an exponent. Do I have an exponent on the parentheses or on the bracket? No, but always look for one because they will come back to get you later. And then finally, the last thing you look for is the coefficient. Coefficient is just a fancy word for a what? A multiplier. So our multiplier here is the 3. That means we're going to take everything inside times 3. So first I'll take the 3 times the 4x. Well, 3 times 4 is 12, and nothing times x just stays x, right? Good. So we've done the first term. Now we'll take the 3 times the positive 1. And remember, we have a sign there, so we have to keep it. So positive times a positive stays a positive. And 3 times 1 is simply 3. Now can I combine those? I can't just add 12 and 3? No, because that's not a 12. It's a 12 what? 12x. Good. Okay. All right. Will it change if I have more stuff, do you think? More letters, more numbers? Absolutely not. It's exactly the same process. You're just going to get more complex answers. So look at this one. So we have 3x times 4xy plus 2. So that's the same. First of all, we'll look inside. Can I take a 4xy plus a 2? Can I add those? No, because they're not like terms, right? That's an xy term and that's a constant, so they can't be combined. There is no exponent, and again, that's very rare, but it will come later. What is my multiplier, my coefficient here? 3x. So that means multiply everything inside by 3x. So first, I'll take the 3x times the first term. So taking it in pieces. Remember, when you're multiplying terms, first you do the sign, then you do the coefficient, the number part, and then finally the base and exponent. So 3 times 4 is going to give me what? Y'all are very brave. 12. X times an x. This time I have another x in there, so I can multiply those together, right? What's x times x going to make? Not 2. Well, it's just going to be, remember, it's x to the first times x to the first, so x to the second, or x squared. Okay, remember, when you're multiplying with the exponents with bases, you just add the exponents. But then I also have this y. But do I have anything out here to multiply that y by? So will the y change? So I just get to drop it off and leave it? No way. I can't lose it, right? It's just going to come down unchanged. Okay? Don't lose any pieces. Nothing ever disappears. Now, so I've finished with the first term, but I still have to multiply everything times that positive 2, right? So a positive times a positive is still a what? positive. And because it's between two terms, we have to have a sign, right? Then 3 times 2 is 6. And x times nothing just stays x. Excellent. Now I have those two terms. Can I combine these two terms?
No.
But they both have an x in them. Doesn't that mean they're like terms?
Yes, yes. No.
Look at my face. What do you think?
No.
No, because this is not even an x. That's an x to the what? X to the second, right? So, yes? No, if you multiplied another x, multiplying is what changes. Remember, exponents can only change by multiplication, right? But if you add x's, that's one of them plus another one of them, which makes what? 2 of them. It's like having apples, right? Apple plus another apple means you have 2 apples. Same thing there. So combining is different than multiplying. Multiplying changes which part? The exponent. But combining changes which part? The coefficient. Okay? So be careful about that. All right. Let's look at some more. Okay? So remember that when you're writing with multiplication in algebra, do you even have to write a symbol at all? No. 8 times x times y is the same as 8xy. In other words, if things are just put together like that, that always indicates what operation? Times multiplication. You betcha. It can never be anything else. Okay? All right? So, anytime you're multiplying terms, then you just multiply the parts you can, and then anything you can't multiply just kind of follows along. So if you look at this one, 4x times 2y, I can multiply the 4 and the 2, right? 4 times 2 gives me what? 8. But can you multiply an x and a y together? Well, I can't really multiply them together, but I can just what? Put them side by side and turn it into a what? So, it's right here, guys. Anybody want to play with me today? 8, what? xy. Okay? So you can't really multiply 2 letters together, but you can put them side by side so that they are, and that's what's considered to be multiplied together. So it's your simplified form. Remember, in algebra, we don't write anything that we don't have to write. Okay? So here they're just showing you more multiplication. We've done that. All right. Okay. So anytime you're expanding, means multiplying everything inside the bracket by the term on the outside, right? And simplified means removing multiplication signs, coefficients, etc. So simplified just means make it as simple as possible without any of the further pieces. So here you go. This one's a little different. You want to work this one together, or do y'all want to do it? Okay. Did you all have your tea this morning? You seem a little groggy. Okay, here we go. So first thing, the order of operations tells me I have to always look for what first? Brackets. Do I have any?
Brackets.
You betcha. Thank you. I like the enthusiasm. Y'all are back to where you normally are. Okay, so brackets. Do I have any brackets up here? Yes. So that means I have to do the brackets first. Excellent. And let me show you something. Excellent. Let me show you something really important. Guys, all right. The bracket actually starts with the 4x because that 4x is part of the bracket. It's its coefficient, right? So anything that touches the bracket is part of the bracket. Okay, but hold on a minute. Hold on. Okay, but is this part of the bracket?
No.
Isn't there an operation symbol between it? So it doesn't touch it. There's an operation symbol between it. So those operation symbols separate it from the bracket.
Isn't there an operation symbol between the 4x and the bracket?
There's an assumed one. What is it? Multiply, right? But times is the one that it behaves differently, right? Times connects all things together, but plus or minus separates things from each other. Okay? Well, divide would be a fraction, so it would just still be all one piece, right? So divide is kind of like multiplication. So it's the same way. So addition and subtraction separate things from each other, but multiplication pulls things together. So we do have a bracket, and the bracket that we have starts at the 4x and goes there. So is the plus 3x part of the bracket?
No.
And I'm not. So that means that I'm not going to use it yet. I'm simply going to bring it down. I am going to be looking for that when I grade your papers. You have to bring it down because you're not using it yet. Then you can go back and work on the stuff that you can use, which is the bracket. Okay? So here's our bracket. When we're dealing with a bracket, where do we look first? Starts with an I. It's what we learned today. Inside. So we're going to look at this inside part first. We're going to look here at this part. So what I have here is I have some addition, right? But can I add a 2x squared and a positive 3 together? No, they're not like terms. This is an x squared term, and that's a constant term, right? So I cannot add them together. Remember, you can multiply anything, but to combine, they have to be like terms. Good, so there's nothing to do inside. Is there an exponent here on the bracket? Nope, so don't have to worry about that. And the last thing and most common thing is to look for a multiplier out front. Is there a multiplier or a coefficient in front for this? Yes, what is it? 4x. Excellent. Which means I need to take that 4x times how many of the things inside?
2.
Yes, times both of the things inside, right? Excellent. So let's do that. 4 times 2 makes what? 8. X times x to the second makes what? X to the third. Excellent. Good. Because remember, it's the same as saying x to the first times x to the second, which is x to the 1 plus 2. Right? Remember, when you're multiplying with letters, you just add the exponents. And if it doesn't have an exponent, you assume it to be a 1. So don't forget it. Okay? Now, that's that whole term done, right? But now I have to take the 4x times this positive 3. Well, it's a positive times a positive, which is still going to make a what? Positive. And because you had that plus inside there, you have to have the plus in your answer. And then numbers can be multiplied together. So what's 4 times 3 going to make? 12. But what's x times nothing going to be? Can it change? X times no more x's just stays x. Okay? Now that I've done all the steps, the parentheses are gone. But am I done with this problem?
No.
Why not? I've done.
Still got stuff outside the bracket.
There you go. If you look at these two pieces, what do you notice about them? 12x and 3x.
Like terms.
They're like terms, exactly. They're both x terms. Now, how about this 8x to the third? Is that like terms to the other two? No, because the exponent is different. So the 8x to the third is just going to come down. Positive 12x's plus 3 more x's is going to make what? Positive 15x's. Excellent. And remember, when you're combining, it's just the coefficients that change, not that it doesn't become an x squared. It would only become an x squared if you were doing multiplication, right? And so there is your completed answer. You're loving it, right? You don't love anything this morning, you guys. What's going on? You guys are all...